Hello, everyone. Today, I'd like to talk about the mechanism of deep core control that is related to spinal stability and breathing. Before we talk about deep core, let's talk about what the definition of core is. There can be various definitions of core, but broadly speaking, our core refers to the musculoskeletal structure that are used for stabilizing our trunk and pelvis. If we consider the fascial connection among many different muscle groups, we can argue that there are no such thing as deep core and outer core that's depicted in this picture. Then what is the benefit of conceptualizing the deep core? The deep core muscles are capable of stabilizing our spine and pelvis without necessarily changing the posture of these structures. The following muscles are commonly classified as deep core muscles: our diaphragm, transverse versus abdominis, pelvic floor, and multifidus. Now, as you can see in the picture, these muscles encloses the abdominal cavity as if they are forming an abdominal canister. Such design allows them to generate and control the pressure inside our abdomen to stabilize the core. According to Dr. Stuart McGill, activation of one of the outer core muscles has to be accompanied by the activation of the opposing muscle in order to stabilize our spine. Just like how it is depicted here, that the abdominal muscle here, activation of the abdominal muscle needs to be opposed by activation of erector spinae muscle. Such co-activation of the opposing muscles inevitably increases compression of the spine. The pressure-dependent mechanism of the deep core can mitigate the reliance on the compression-dependent stabilization of the outer core. The pneumatic piston in between the springs in this picture is analogous to the role of deep core mitigating the compression to the spine. Now, importantly, deep core's role for controlling pressure inside the abdomen is closely related to how we breathe. In addition, motor control of the deep core muscles are known to be easily altered by injuries or pain. For this reason, retraining the motor control of deep core muscles has been a fundamental component of the rehabilitation of clinical conditions. However, these days, we frequently see non-optimal function of the deep core as well as altered breathing among the non-clinical population. This is presumably because of the postural habits and lifestyle many people have adopted, such that they put their deep core muscle groups into non-optimal length for a prolonged amount of time. That is why retraining of posture and deep core muscles are becoming more and more important, even in so-called general fitness training. Let's look into how deep core stabilization is closely related to breathing. As we breathe in and out, the central portion of the diaphragm goes down and up. This action of the diaphragm can change the pressure within the abdominal cavity. It can also compress and decompress the abdominal contents. Especially when the diaphragm descends, It creates more pressure within the abdominal cavity and compresses the abdominal contents down. But we don't want drastic increase of the intra-abdominal pressure, nor we want to compress our gut too much. So our body allows our gut to spread out to the side as our abdominal walls eccentrically activate, meaning they lengthen and activate at the same time to maintain the steady pressure as the volume of the abdominal cavity increases. The picture on the right-hand side shows that more clearly, and the pelvic floor would do the same thing, the similar thing, as it allows the abdominal contents to descend. It eccentrically activate to receive and stabilize them. Its eccentric activation also exerts upwardly oriented pressure so that we can maintain the steady pressure inside the abdominal cavity. So in summary, descending action of the diaphragm generates the pressure within the abdominal cavity, and this is coordinated with eccentric activation of the abdominal walls and the pelvic floor so that we can maintain the healthy amount of intra-abdominal pressure. Now, we need to understand how this intra-abdominal pressure is used for stabilizing our spine and pelvis. This picture is a bird's eye view of our abdominal cavity. And the blue arrows represent the intra-abdominal pressure directed outward. As you can see, the pressure directed towards the spine is opposed by the tension created within the thoracolumbar fascia as the abdominal wall lengthens. And the eccentric contraction of the abdominal walls can modulate the balance between these two forces so that the net pressure created by these three forces work like a strong buttress for the spine. So far, we talked about descending action of the diaphragm, which is more related to inhalation. So what about exhalation? Well, obviously, the diaphragm would ascend back into its initial position, right? Interesting thing is that for the quiet breathing, this is rather a passive action. The exhalation is rather a passive action. During the descent of the diaphragm, the lungs will be stretched due to the fascial connection between the diaphragm and the lungs. Exhalation is driven by the recoiling of the lungs. The abdominal walls also rather passively facilitate this exhalation because they just recoil after being stretched. This way, our respiration can occur without the drastic change of the intra-abdominal pressure. As we are under a heavier workload, the breathing becomes more forceful and the action of the abdominal wall becomes more active. But we should still be able to control the changing pressure within the abdominal cavity. To optimize the control of our core and breathing in various situations, we need to understand that there is a trade-off between the stability and respiratory function of the deep core. An example of the situation where the deep core is used entirely for breathing at the end of this spectrum is relaxation breathing, where there is no eccentric abdominal tension during inhalation. This is very similar to what is often used for meditation. An example of the situation where the deep core is used entirely for stability function is a Valsalva maneuver where the diaphragm stays in isometric contraction in its lowest position while we hold the breath. Many power lifters use this method when lifting a very heavy weight, like, and then hold the breath, just like this. Ideally, we should be able to play within the entire range of this respiration, stabilization, trade-off spectrum. To be able to do so, we need to establish the ideal coordination among the deep core musculature during a quiet breathing. We will go over how we can identify the altered coordination among the deep core muscles and how we can correct this during the quiet breathing.